Hello all. So in the last class we have seen the equation of the tangent at a given point x1 y1. So if you have uh, the equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0, which represents a conic, then the equation of tangent line at point x1 y1, that will be given by, so you have to replace x square by x1, then 2xy by xy1 plus x1y, then we have b by y1, then g x plus x1 വരും plus f y plus y1 plus c equal to 0. So this was the uh, standard equation of the tangent at the point x1 y1. So in today's class we will see uh, the condition that a given line will touch the conic. So let us take a conic and an arbitrary line. So we will look for the condition that the line will touch the conic. So condition that a given line may touch the conic. So let us consider the equation of the conic. So this is the standard equation of a conic, and let us take the general form of a line. So let the equation of the conic and the line be ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0, and let's take the equation of line as lx plus ly plus n equal to 0 respectively. Then we have lx plus ny plus n equal to 0, so therefore y will be minus lx plus n by m varum. Now substituting this in the equation of conic, so we need to find out the condition that the line will touch the conic. So therefore this value of y will satisfy the equation of the conic. So upon substituting this in the equation of the conic, so we will get, so we will have ax square plus 2h x minus lx minus n by n plus by square upon x plus n by n whole square minus 4 plus 2g x plus 2f minus lx minus n by n plus c equal to 0. So that is going to give, so first let us take the coefficient of x square, so that will be a plus b n square by n square minus 2h n by m varum. Then the coefficient for x will be minus 2h n by m, ഇവിടുന്ന് 2l n by m into p വരും plus 2g minus 2f l by m. Then the constant terms will be is Pn square by m square minus 2f n by m plus c equal to 0. So let us take the common denominator. M edukka common denominator, m square edukka. So upon simplifying, you will get the equation as x square into am square minus 2hln plus bl square minus 2 വെളിയിൽ എടുക്കുക അപ്പോൾ h mn minus bln minus gm square plus fln. Then we will have 3 terms in the last constant of b n square. Okay, the n square common denominator under minus 2f ln plus c m square equal to 0. The conic and the line intersect with each other, then this equation holds. Now we need to find the condition that the given line will touch the conic. That means lx plus my plus n equal to 0 becomes tangent to the conic. Okay, tangent what happens here is, so this is a quadratic equation, so there will be only a single point of intersection. Now that means there is exactly one root for this equation. So roots real and equal ആയിരിക്കണം. So this happens when the discriminant is equal to 0. So therefore b square minus 4ac must be equal to 0. So let us find out the condition using that. So if the line lx plus my plus n equal to 0, the tangent, then the roots of this equation must be equal. So that implies b square minus 4ac must be equal to 0. So that will give 4 HMN minus BLN minus G M square plus FL M whole square minus 4 AM square plus 2H, sorry, minus 2H LM plus BL square into bn square minus 2f mn plus cn square. This must be equal to 0. Now upon simplifying this, so 4 will cancel off, 4 cancel here, and upon simplifying you can reduce it to the form. So bc minus f square into l square plus ca minus g square into m square plus ab minus f square into m square plus 2 gh minus af into mn plus 2 hf minus pg into ml plus 2 fg minus ch into ln equal to 0. So this is the condition, and that can be also put in this form. So it is the required condition. So just remember the idea of how to find the condition. So conic തന്നിട്ടുണ്ട്, line in the standard equation തന്നിട്ടുണ്ട്. So if they intersect each other, the line will satisfy, so you will get a point of intersection. So point of intersection will be given by substituting the equation of line into the conic. So now it will become a tangent provided it has a single root, but the discriminant must be equal to 0, so that gives the condition. So remember that our conic is a circle with the equation x square plus y square equal to a square. So let us look on what is the condition. Okay, from നമുക്ക് L, M, N that will remain the same. So here you will have A equal to 1, B equal to 1, H is 0, then G is 0, F is 0, and C will be equal to minus A square. Okay. So therefore, upon substituting the condition, so we will get the condition as, so we are going to get BC minus F square, so that is minus A square L square plus CA minus G square varum. So that will be minus A square into M square plus AB minus F square. So that is 1 into N square, then GH minus AF, that will be 0, then HF minus BG 0 agum, then FG minus CH will become 0, so this will be the condition. So what is N square equal to A square into L square plus M square. So that will be the condition satisfied if the line is touching the circle. Now in case of parabola, so you have y square equal to 4ax, so that implies y square minus 2 into 2a x equal to 0. So a is 0, h is 0, b is 1, g is minus 2a, and f is 0, c is 0. So we will obtain the condition as, when you substitute in the equation, so the condition for parabola will be of the form am square minus ln equal to 0. So that implies n equal to a m square by l. And similarly, when you find the condition for ellipse, so you have x square by a square plus y square by b square equal to 1. So here in place of a, you will have 1 by a square, then in place of b you will have 1 by b square, and c will be equal to minus 1. So h, g and f, so all will be equal to 0. So in the case of ellipse, the condition will be, so we will get a square l square plus b square m square equal to n square. And in the case of hyperbola, x square by a square minus y square by b square equal to 1. So when you apply the condition, you are going to get the condition as a square l square minus b square m square equal to n square. So these are the conditions for these conic to touch the